Hello viewers, in today's class we are going to solve one important and definite integral which is of the form uh, dx over p plus q times sin x plus r cos x, right? So here we are given a definite integral, but if we take the indefinite integral form of this integral, then we have this type of integral, right? So 1 over p plus q sin x plus r cos x, right? Okay, so now here what we will do to evaluate this integral, we'll first of all consider the denominator, right? So the denominator of this integrand is 3 plus 2 sin x plus cos x, right? And now we'll express this integrand in terms of half angles, right? So here the angle is given as x. So now we'll use some trigonometric identities to convert this integrand in terms of uh, uh, trigonometric functions having angle x over 2, and let us see how we can do this, right? So 3 plus 2 sin x plus cos x can be written as 3 multiplied by 1 plus 2 sin x plus cos x, right? So 3 can be written as 3 multiplied 1, right? Okay, now see, this 1 can be written as sine square x over 2 plus cos square x over 2, because we know that the identity sine square theta plus cos square theta is equal to 1. But here we have taken for theta we are taking the angle x over 2, right? Okay, now for sin x we can write 2 times sin x over 2 cos x over 2, right? So here what we have done, we have expressed this sin x in terms of half angle. So we have used sin x is equal to 2 sin x by 2 cos x by 2, and for cos x we can write cos square x over 2 minus sin square x over 2. So these are the famous trigonometric identities, so we have used them here, right? So what we have done here, so here in the original integrand we have the angle x. Now we are using the trigonometrical identities in which the angle half angle x over 2 is involved, right? So now this is the step here, and we have expressed this denominator which is of this form, where p is 3, q is 2 and r is 1, right? Okay, so now we can simplify this. So we have 3 sine square x over 2 plus 3 cos square x over 2 plus 4 sine x over 2 cos x over 2 plus cos square x over 2 minus sine square x over 2. Now 3 sine square x over 2 and sine square x over 2 is equal to 2 sine square x over 2, and 3 cos square x over 2 and 1 cos square x by 2 is 4 cos square x over 2, right? And this is the term having the product of sine x over 2 and cos x over 2, right? So once we have expressed the denominator in terms of sine x over 2 and cos x over 2, so now I will substitute it here, right? So let us call this integral as I. So now I can be written as 0 to pi and dx, and we have 2 sine square x over 2 plus 4 cos square x over 2 plus 4 sine x over 2 cos x over 2, right? Now what we will do in next step, we'll divide the numerator and the denominator by cos square x over 2, right? So now dividing the numerator and denominator by cos square x by 2, we get this result, right? So 1 over cos square x by 2, and each term is divided by cos square x by 2, right? So now this integral can be written like this: 1 over cos square x by 2 is secant x square sec square x over 2 dx, and here we have 2 tan square x over 2, because sine over cos is tan and we have the square term, and now these two get cancelled, so we are left with 4 plus here we have cos x by 2 and 1 power get cancelled, so we have 4 sin x by 2 divided by cos x by 2, that is 4 times tan x by 2, right? So this is the integral which we want to have, or we have reduced this integral into this integral, right? So here we have tan x over 2 and secant x over 2, right? And the derivative of tan x by 2, it exists in the numerator, right? Now here we will apply the method of substitution. Now let us take t is equal to tan x by 2. So therefore dt over dx is equal to half sec square x over 2. The derivative of tan x by 2 is half sec square x by 2. So therefore dx is equal to 2 times dt, and here we have for dt we have 2 dt, we have sec square x over 2 dx, right? So 2 dt is equal to sec square x by 2 dx. Okay, now let us change the limits here, because here x varies from 0 to pi by 2. So when x is 0, t is tan 0 over 2, that is tan 0, which is 0, and when x is pi by 2, we have here we have the upper limit as pi, so here we have x equal to pi, so t is tan pi over 2, that is tan pi over 2 is infinity or not defined, right? So therefore this integral now reduces to 0 to infinity, and secant square x by 2 dx is equal to 2 dt, and in the denominator we have 2t square plus 4 plus 4t, right? Because t is equal to tan x by 2. Now cancelling the factor 2 in the numerator and denominator, we have t square plus 2t plus 2, right? Now converting this quadratic factor into a perfect square, we have dt, and this can be written as t plus 1 square plus 1, right? Because t square plus 1 square and 1 is 2, and then 2ab term is 2t, right? So this quadratic factor can be written like this. Now here again we can make use of the method of substitution. So let y is equal to t plus 1. So therefore dy is equal to dt, and when t is equal to 0, y is equal to 0 plus 1, that is 1. And when t is equal to infinity, we have y is equal to infinity plus 1, that is infinity, right? So now this integral reduces to 1 to infinity, or and for dt we have dy, and for t plus 1 we have y, so we have y square plus 1, right? Now this integral is a standard integral, and we know that dx over x square plus 1, the the integral of 1 over x square plus 1 is tan inverse x, right? So here we have I is equal to tan inverse y, and the limits are from 1 to infinity, right? Okay, so now we can substitute the limits and we'll take the difference. So we have tan inverse infinity minus tan inverse 1, and tan inverse infinity is pi over 2, and tan inverse 1 is pi over 4, because tan pi by 2 is not defined, so pi by 2 is tan inverse infinity, and tan pi by 4 is 1, so pi by 4 is equal to tan inverse 1. Now pi by 2 minus pi over 4, the difference is 2 pi minus pi over 4, so this is pi over 4, right? So viewers, this is how we solve this problem, and the value of this integral is pi over 4, right?